Okay, so we have already looked into the filters, okay, type of filters, and then the configuration or placement of the filters. So it is quite important to make sure that you select the correct configuration of the filters. So now let's look at a common hydraulic system problem. Okay, these are the problems that we normally have in a hydraulic system. So later I will share some pictures, okay, of wear, sticking, oxidation, thermal stability, and contamination problems that we have in a hydraulic system. Okay, so what is wear? Okay, wear means when you continuously use a hydraulic system, after sometimes the seal and the places where there being a surface touching to another surface, and it will become wear. Okay, old. Okay, okay, wearing, similar like your shoe. Okay, if you continuously wear, what will happen to the your shoe? After sometimes it will become wear. Okay, so similar to hydraulic system, after when you've been using the component for a very long time, the components of hydraulic will start to wear off. So we also have sticking. Okay, sticking is happens when the oil is the condition of the oil is thick. Okay, once the oil is thick, and then you, for example, you never operate your hydraulic system for quite some times, and then when you start to operate the hydraulic system, you will face this problem, okay, sticking problem. Once when you never run your hydraulic system for a specific frame of time, okay, a long frame of time, it will cause sticking problem. Okay, and then you have oxidation. Oxidation is a cause of oxidize. Okay, if you are using oil, okay, oil in your tank, for example, so it will become oxidized into the inside the tank and become a one-ish surface on the tank. So I will show you example picture of this. Okay, the oxidized surface is a sticky surface. Okay, it looks like a dirt and it's very difficult to be cleaned up. Okay, and then we have thermal stability. Okay, thermal stability is a characteristic that we require in a good oil. Okay, your good hydraulic oil must have a good thermal stability. Okay, what is thermal stability? Okay, the hydraulic oil should be in certain range of temperature. Okay, let's say you have this is your max. Okay, max degree Celsius. Okay, and then you have mean degree Celsius. Okay, so your oil should be in this. Okay, cannot up, cannot down. Okay, if your oil can maintain in this range, okay, during the operation, and then the oil has a good thermal stability. Okay, if the temperature increase over this or the temperature decrease over this, then it does not have a thermal stability. If your oil has a very good thermal stability, then remember the cooler and the heater. Okay, the cooler and heater uh, need not to perform a function to stabilize the temperature. Okay, so it's very good to have a oil with a good hydraulic oil with a good thermal stability. So just for your extra knowledge, so hydraulic oil, okay, how do you know that the oil is for hydraulic oil? So normally the hydraulic oil viscosity is viscosity, okay, viscosity. This you already learned in your previous topic, I believe. Okay, viscosity is how thick is your oil. Okay, we have numbers there. We have 32, and then we have 68, and many. Okay, okay, this 68 is being used for the hydraulic. Okay, hydraulic system. If you say, for example, HLP 68. Okay, so that means the hydraulic oil 68. Okay, 32 is normally used in a pneumatic. Remember last week I taught you about pneumatic lubricator. Lubricator oil is a 32, size 32. The viscosity is 32. So that is for the viscosity. Okay, when you buy the oil, hydraulic oil, the viscosity in most of the hydraulic system, they are using 68. the thickness of oil is 68. Okay, and then finally we have contamination. Contamination can come from the components which are being installed into the hydraulic system. So for example, you have a cylinder here, okay, cylinder, then you have a piston here. Okay, you know that there's a seal here. Okay, you have a seal for the piston here. If dust, dirt, and all this start to stick on your piston rod, okay, when your piston goes in and out, in and out, in and out, this dust and dirt is going inside your oil. Okay, going inside the oil, and after that it will go to your pump. Okay, once when it go to your pump, it will start to contaminate your oil. Your oil become contaminated. Okay, dust, normally dust and dirt particles. Okay, we have dust, dirt particles, small dirts. Okay, dirt particle. So this is going and this cause contamination. So all these are problems of the hydraulic system. So now we will look into some examples of each and every of these problems. Okay, you can see here, what you can see here is a pump. Okay, this is a pump, rotating pump. Okay, you can see here it is rotating here. So when this pump is rotating, let's say for example, you did not provide a good hydraulic oil, okay, or the oil is insufficient, or the temperature of the oil is not appropriate, okay. So for such cases, so what will happen? There will be frictions between the rotating part and the stationary part, okay. This will cause wear and sticking. So you can see the wear, okay, wear part. Sticking happens, okay, it will not move in a smooth flow. So that means it start to stick. So you have wear and tear. So this is a problem of the one of the problem, okay, which wear and sticking. So how you can notice this? Okay, we can only notice sometimes there's a yellow, yellow, yellow metal transfer from the piston shoes. You can see that there's a yellow deposit, yellow deposit on the piston surface. Okay, and the color is different. Okay, you can notice the different color here, another different color here. So you can know that it's starting to wear. Okay, these are some of the observation that you can do during the maintenance. Okay, when you open up the hydraulic system and then you just observe the color of the components. Okay, the surface of the components. Okay, if you have discoloration, that means the component is starting to wear. Discoloration is a different colors. Okay, here different color, here different colors. So this is another example, excessive scoring and scratching. Okay, this is more critical. Okay, this happens when there's completely no oil. Okay, or maybe the oil is the pump oil is not sufficient to fill the whole system. So certain part of the system, they may not receive the oil. So you have this problem. Okay, when you first start your system, when it start to move, okay, it will, the other side of the system, it will move without oil. So you have a scoring or scratching happening. This is a very critical problem. Okay, scoring and scratching, but very seldom. Okay, so we only have a wear. Most of the time we have a wear problem. Okay, next, this is, as I explained to you before, this is not a room. This is a hydraulic tank. Inside the hydraulic tank, okay, hydraulic tank, we have oil inside. Okay, in normal operation, there is oil until here. Oil will be filling until here. We have oil all over here. So oxidation happens. Once when oxidation happens, the oil will stick on the surface of the tank and become a one-ish. Okay, sticky surface, one-ish. So this will collect dirt. Okay, dirt and particles will collect on the one-ish, and if the, for worst scenario, it will cause the damage of the components, or the movement of the components will be jammed. Okay, this is an oxidation problem. So sticking. So this example we have taken from the valve. This valve, they start to stick. Okay, because the operator did not use the machine for many years. Okay, so after many years they want to reoperate the machine, and they found out the valve is sticking. Okay, the oil is very old and it will start to become glued, and the operation is not possible. Okay, so this is another problem. So if your hydraulic system is not running, then you have to make sure that every periodically, maybe 2 or 3 days, you have to run and warm up the system to make sure that this doesn't happen. Okay, thermal stability. So this, as I explained to you earlier, so when you buy hydraulic oil, you have to check for this important parameter. Okay, thermal stability, characteristic of the oil. A good oil should have a good thermal stability. That means the oil is stable. Along the process, the temperature of the oil is stable. It does not increase or does not reduce. So this is a characteristic of a good oil. So important here, for every 10 degrees Celsius rise in the operating temperature above 60 degree, oil life is cut into half. For example, your oil you can use for 1 year. Let's say 1 year, 6 months. Okay, let's say 6 months, and if you're operating your oil in 60 degrees Celsius, and then suddenly you increase to 70 degrees Celsius, that means your oil will only last for 3 months. You already lose half of the oil life. Okay, so every 10-degree increase, the life of the oil will reduce half. So initially, if you run at 60 degree, the oil can last for 6 months. Okay, but if you run in 70 degrees Celsius, it only can stand for 3 months. Then after 3 months, you have to change your oil, hydraulic oil. Okay, this is a spool, valve spool. Okay, taken out from the valve. It's a valve spool. Inside the valve. Okay, what happens when you have high temperature? Okay, as I explained to you earlier, you have oxidation. So oxidation happens. You have varnish here. Okay, varnish, oxidation, due to oxidation, and you have dirt all collecting on the spool. So what happens when you have this? The switching of the valve will be slow or intermittent, or it does not switch. Okay, this is caused by poor thermal stability. Poor thermal stability will cause oxidation. Okay, this is, you should remember this. Okay, next part. This is another example. This is a pump. Okay, swash plate pump. Okay, let's say, for example, the swash plate pump here, we using fluid with poor thermal stability. This is what happens. Okay, you're going to have a copper varnishing, yeah, a copper varnishing, and then the wear and tear here. Okay, and then the surface here is the oil. Okay, oil varnishing here. Okay, this is copper varnishing. Initially the plate was like this. Okay, this is the initial pump plate, swash plate. Then it happens after you run with the poor thermal stability oil, it becomes like this. So you notice the what happens when you use a poor thermal stability oil in hydraulic system. Okay, and then particulate contamination. Particulate means, as I explained earlier, the dirt and dust which accumulate on the actuator, piston actuator, goes into your system. Okay, when it goes into your system, your oil already contaminated with dust, dirt, and all this. This dust and dirt will scratch your hydraulic parts. See, there's a scratching here. Okay. Okay. Once when you start to scratch, then you're going to face the component is going to wear and or spoil and damage very soon. Okay. Okay, so finally, okay, you have already seen all the problems that we have in a hydraulic system. Excuse me. Okay, so now let's summarize this. Okay, we summarize. So in order to make sure that our hydraulic system is in good order, so what we need to do, and this is common activities, preventive maintenance activities. So as you learned earlier, maybe you have learned earlier, preventive maintenance is what you need to do periodically. Okay, maybe after every 3 months you need to do this, every 6 months you need to do this, and so on. So this is preventive maintenance. Okay, so normally every 3 months you need to replace the hydraulic filters depending on the requirement. Okay, some machine 6 months, some machine is 12 months. Okay, depending on the requirement you need to replace the filter. Okay, and then take hydraulic oil samples for lab test. Why do we need to send for lab test? Okay, so normally they take out the hydraulic oil, sample, they put in a bottle here, and then they send to a lab test. So why do we need to do this? Because in the lab they can identify, they can do some test on the oil, and they can identify if there is any contamination existing in the oil. Okay, this is the reason why you need to send it for the lab test. If there is a contamination, that means certain part of your hydraulic components need to be cleaned or need to be checked the source of the contamination. And then check for scratches. Where you can check scratches, normally the easiest part is the cylinder. Okay, you have a cylinder, you have a piston here. Okay, so you can check here on the surface of the piston rod to check if there's a scratch, okay, or a bend. Okay, sometimes maybe the rod is a bit bent. Okay, a bit bent like that. Okay, what happens when bent? Okay, it will start to scratch inside. So you need to check for scratches. This can also be checked in motors. Okay, any moving part of the hydraulics, which is obviously outside. Okay, the machine. And then the tightening of mounting and fasteners. So if you have mounting, for example, mounting is brackets. Sometimes you have cylinder brackets and all this, and then you have a screw here, you nut. Okay, okay, this is mounting. Mounting holds the actuators or valve on the machine. Okay, so you have to tighten the nut, you have to tighten the screw to make sure there's no vibrations of the components when the operation. Okay, tightening and mounting. And clean hydraulic tank. Okay, as I showed earlier, you have to flush the hydraulic tank, and then you have to wash inside. Okay, so you need to clean up the hydraulic tank, internal and external. Inside, you need to clean up. When you have the place where the oil is stored, you need to clean up. And external, outside the tank, okay, probably there's a dust or any rust and all this, you have to clean up. And then next, check and record daily hydraulic oil pressure. You need to check oil pressure every day. Okay, so let's say you measure, maybe first day you get 30 bar. Okay, second day you get 30 bar. Third day maybe you get 35 bar. Okay, and then fourth day you get 40 bar. There's something wrong here. Okay, the pressure is increasing. So whenever you notice this, then you should troubleshoot on the system to check why the pressure is increasing. Okay, the pressure of the hydraulic actually indicate the healthiness of the hydraulic system. Okay. Similarly, if you have a 30 bar and then 30 bar and suddenly your pressure drop to 25 bar, and then you need to check why suddenly your pressure drop. This is also a problem. Pressure cannot drop, pressure cannot increase. Pressure has to maintain at the healthy range. Okay. So next you have what is the healthy range? Okay, someone asked me what is healthy range. Okay, the range for the hydraulic pressure and temperature is not the same for all system. Okay, you have to refer back to the manual of the machines that you are using. Okay, you have to check. There are many types of hydraulic pressure. You have high pressure hydraulic, medium pressure hydraulic, and low pressure hydraulic. So the specification of each system is not the same. Okay, but the main concept is that you have to make sure that the pressure of the hydraulic is maintained at the very healthy level as according to the manual of particular machine. Next, you have hydraulic hoses. Check hydraulic hoses, tubing and fitting. Hydraulic hose you have to check. Okay, make sure there is no leakage, and then make sure you cannot roll your hose like that. Okay, you cannot hold. Okay, why you cannot roll the hose like that? This is causing friction. Okay, when you roll this cause friction. When you roll like that, your pressure is going to increase. When your pressure increase, your coupling will become affected and your coupling will spoil, or your hose will burst, and or you have leakage all around your hydraulic system. So basically you have to do these 8 steps. Okay, these are common activities, preventive maintenance activities for a hydraulic system. Okay, so summary, from this lesson, we learned that the most of the maintenance costs are being spent to maintain the pump, okay, because it is the most critical part of the system. Secondly, we learned that the hydraulic is divided into 3 categories. We have a drive section, we have power control section, and we have power supply section. Okay, 3 sections here. And then thirdly, there are 3 configuration of the hydraulic filter. We have a return flow filter, pump inlet filter, and pressure filter. Okay, finally, you looked into the problems which you have in hydraulic system. You have wear, you have sticking, you have oxidation, which cause varnish. Okay, this is create varnish on the hydraulic component surfaces. And then you need oil with a good thermal stability. Okay, oil with a good thermal stability and contaminations.